Okay, in chapter 8.2, we will continue with the testing of the mean, but now it is important to realize that sigma is unknown. And if you recall, when sigma was known, our test statistic was a z-value. When sigma is unknown, we will now have to use the student's t-distribution table instead of the z-table. So that's what's very important to remember. Now, S, which is the sample standard deviation, will be given. So again, we're going to go through the 5 steps. Some of them are the same, some will have changed. Step 1, the setting up of your hypotheses. If you'll notice, this is exactly the same as we did in the last lecture. The null is mu is equal to a number. The alternate is mu is less than, greater than, or not equal to a number. So this is the same as what we did before. Hasn't changed. Now, here is where it changes up. If you will see, this is still the test statistic, but now this is a t-value instead of a z-value. So we will not use the z-table. Now the formula in essence is the same, x bar minus mu divided by, but this is S, sample standard deviation instead of population standard deviation, divided by the square root of n. So now instead of using the z-table, we are going to have to use the student's t-distribution table, which we used this table in chapter 7. So I'm going to write that over here. This tells me to use the student's t-distribution table. And again, the reason why is because sigma, the population standard deviation, is unknown. So step 3, so this was different. You can't really see that. This is different in that we still find the p-value, but we use the t-table instead of the z-table. Now, step 4, the decision. We still compare the p-value to alpha, and this is exactly the same. And the conclusion, these 2 steps are exactly the same as what we did previously. So that does not change. Now, how we use the student's t-distribution is different. So let's look at finding the p-values when we use the t-table. So this says, at the top of the student's t-distribution table, you have 3 rows. So here what it's talking about is we have 1 tail area, 2 tail area, and then we have C. Now, we've dealt with the DF, which is n-1, and we dealt with the C, which was how confident that we are. Well, now for chapter 8 in the testing, what we are going to use is the 1 tail area and the 2 tail area. So we will use the values next to the 1 tail area when we have a 1-tailed test. And the 1-tailed test is when your alternate is a less than or a greater than. That means you have 1 tail. And then if you have an is not equal to, we will use the 2 tail area. So these numbers here are your p-values. It just depends if you have a 1 tail area or a 2 tail area. So we are just going to first get familiar with using the table because it is quite a bit different. Okay, so if you look here, it tells us left-tailed test, right-tailed, 2-tailed, left-tailed, 2-tailed, right-tailed. If you'll notice for all of my examples, I used n is equal to 12. So for each of these, my DF will not change. So for this whole page of examples, your DF is 12 minus 1 or 11. So what that tells me is for all of these examples on this page, our DF will be 11. So we'll always be using this row of numbers. Now, the T that is given, this is your test statistic that would have been calculated in step 2. And what we're going to do on each of these is find the p-value, which is your step 3. So here's what I want to notice. The left-tailed test would have been determined by the alternate. That would have told me that the alternate was a less than statement. But for purposes of using the student's t-distribution, what's important is to recognize then that you have one tail area. My DF will be 11, which we've already done that up here. And so I am going to look for the test statistic, 2.201. And again, this would have been calculated in step 2. We're assuming that's already been done. All right, so I'm going to go to my table. And I'm going to go to the DF of 11. So what that tells me here is that I'm looking for the test statistic. All of these are test statistics, and I'm looking for 2.201. And I locate it exactly. So to find my p-value, I come up here to the top rows, and ours is a left-tailed test, which is a one-tail area. So that tells me that 0.025 is my p-value. So my p-value, which again, this would be step 3, is equal to 0.025. And then in step 4, this is what we would compare to our alpha. Now, that example was nice and neat because the number we were looking for was exactly on the table. But unfortunately, the majority of the time, that number, that test statistic, will not be exactly on the table. So let's look at this next example. Right-tailed test. Okay, right-tailed would be tell me the alternate is a greater than, which all I need to know is that it's a one-tail area. My DF is 11, and now I'm looking for 1.327. So I'm going to go to my table, and I go back to the DF is 11, and so in this row of numbers, I'm looking for 1.327. Well, here's 1.2, here's 1.36. Okay, well, what I have found is the number I'm looking for would be somewhere in between these two numbers. It would be somewhere in here in between them. So I'm going to come up here, and I'm dealing with a one-tail area. So I come up here, and it tells me then the p-value I'm looking for falls between these two numbers, 0.125 and 0.100. Now be careful on this. When we write our p-value, it's going to be a range of numbers between two numbers, not an exact number. And notice that the number on the right is the smaller number. So when I correctly mathematically write this, then I would say my p-value falls between 0.100 and 0.125. Just doing some erasing on my table so I can write on it again. So what makes it a little bit more difficult now is our p-value falls between two numbers instead of being an exact value. All right, next example. Now it shows me that I have a two-tailed test. And a two-tailed test means I have two-tail area. My DF is still 11, and now I'm looking for 2.56. So, come to 11, 2.56. Okay, here's 2.2, 2.718. So the number I'm looking for falls between these two values. Now, this was a two-tailed test, so be careful when I come up here, I need to be looking at the two-tail area. So the p-value would fall between the 0.05 and the 0.02. And again, 0.02 is smaller. So my p-value falls between 0.020 and 0.50. And what you'll find when the population standard deviation is unknown, that your test statistic, which is the t-value now, when you go to the student's t-distribution to find the p-value, more often it will fall between two numbers. You're not going to see this happen very often, if ever. Okay, we go back to a left-tailed test, so I know I'm doing one tail area. My DF is still 11, and now I'm looking for negative 0.997. So my test statistic was a negative number. So I go here to 11, and I go, well, there aren't any negative values here at all. Well, here's how we handle that. If your test statistic is a negative value, for purposes of the table, since we have a symmetrical distribution, then I know it gives me the same area as if the t was a positive number. Now, my actual test statistic, so if you were entering the test statistic on WebAssign, you would put in negative 0.997. But for purposes of the table, you're going to look for its opposite, or positive 0.997. So I'm going to go back to the DF is 11. And I'm looking for 0.997, which is in between the first two numbers. And it was a left-tailed test, so I'm going to come up here to one tail area. So it tells me that it is between the 0.25 and the 0.125. And again, the smaller number goes on the left. So it would be between 0.125 and 0.250. So my p-value, or step 3, would look like that. All right, we're going to look at two other scenarios that can occur. We go back to the two-tailed test, so I know I have two-tail area. My DF is still 11, and now I'm looking for 0.234. Okay, so we're at DF of 11, and the smallest number is 0.697, and I'm looking for 0.234. 234 is smaller, so it would be to the left of this number. I'm looking at the two-tailed test, so I'm going to come up here to the two-tailed test, and I would know the p-value I'm looking for would fall to the left of 0.5. So I look at this row of numbers, and I look and I say, okay, what is consistently happening to these numbers as you go to the left? They are continuing to get bigger, so that tells me my p-value that is over here on the left is going to be bigger than 0.5. So I would write this as p-value is greater than 0.5, and it would look like that. All right, one last example just on the t-table before we get into an example of a complete 5-step test. Right tail test, so we have one tail area. My DF is still 11, and now I am looking for 6.103. So what do you think I did this time? So the largest number is 4.437, and we're looking for 6.103, which would fall to the right of this. So I come up here to one tail area, and I know the p-value I'm looking for would be to its right. So I look at the one tail area, and I say, okay, as I travel to the right, what is consistently happening with my numbers? And they're consistently getting smaller, so the p-value is smaller than 0.0005. So that would be written as the p-value is less than 0.0005. So that is a look at how the table works and the different scenarios that can occur. So now let's do an actual 5-step test. Refer to a claim that the average cost for a family of 4 to attend a Major League Baseball game is different from $172. A random sample of 22 families reported an average cost of $189.34 with a sample standard deviation of 33.65. Assume the population is normally distributed. Test the claim at the 0.01 level of significance. Okay, so the first thing that we're going to do is set up our hypotheses. So we know this is very similar. We know we're going to have mu is equal to some number, and the alternate is going to be less than, greater than, or not equal to. So I look at that first sentence. Refer to a claim that the average cost for a family of 4 to attend a Major League Baseball game is different from 172. So that tells me different from means my alternate is not equal to. And this is the average of 172, or $172. Now, where you need to be careful is recognizing this right here. A sample standard deviation. So we're not going to use the z-table, so I'm not going to draw the curve over here and do right-tailed or left-tailed. Sample standard deviation tells me I'm going to use the student's t-distribution, which tells me then this alternate, yes, it's a two-tailed test, but for purposes of my table, I know to look for or at the two-tail area. So if this was population standard deviation, I would have drawn my curve. But since it's sample, then I know I want to look for the two-tail area. Okay, so down here in step 2, my test statistic. I know mu is equal to 172. It tells me a random sample of 22, so that tells me n is equal to 22. And those 22 families had an average, or an x-bar, of 189.34 and a sample standard deviation, so this is S, of 33.65. So this right here is very important to catch. Since that is S, you know your test statistic is a t-value, not a z-value. Now, it is still x-bar, 189.34 minus mu, 172, divided by S, 33.65, divided by the square root of n, which is 22. All right, so clear this out. So fraction 189.34 minus 172, denominator, need another fraction, 33.65, denominator, square root of 22, and then I'm going to come over here and I get, oh, it's 22 and I put in 2. So that's a big old oops. All right, so 189.34 minus 172, 33.65, square root of 22, I get 2.42 approximately. Glad I caught that. That would not have been good. All right, so now I'm going to find in step 3 the p-value. And because the population standard deviation is unknown, I know I'm going to use the student's t-distribution table. All right, so in order to do that, I know I need my df, which is 22 minus 1, or 21. So on my table, I'm going to be looking at the DF21, and then at the top, I'm going to look for the two-tail area. All right, so 21, and my test statistic was 2.42. Well, here's 2.0, 2.5, so it's between these two numbers, and this was a two-tail area, so I come up here to the two-tail area, and it tells me my p-value is between 0.05 and 0.02. So in writing that, our p-value is between 0.02 and 0.05. So now what we're going to do is we're going to compare the p-value to alpha. Now comparing the p-value to alpha is just a little bit more involved here because the p-value was between, well, I'm going to write that as a percent. So 0.02, I'm going to write 2%. 0.05 is 5%, and alpha is 1%. Okay? Now, this one's not hard to tell, but I'm going to go ahead. Some students can see this better when it's on like a number line. So let's say we have 0, 1%, 2, 3, 4, 5%. So the p-value is between 2 and 5%. So here's the p-value. Alpha is 1%. So obviously on this, the p-value is greater than alpha. And the decision that we're going to make when it's greater than, then we know to fail to, reject the null, which basically means we have not proven anything. So when we fail to reject, that means there is insufficient evidence. So there is insufficient evidence to conclude the average cost for a family of 4 to attend a Major League Baseball game is different from $172. And again, it's insufficient because we failed to reject. All right, one more example. An insurance company claims that the average automobile on the road today is less than 6 years old. A random sample of 15 cars had an average of 5.4 years with a sample standard deviation of 1.1 years. Assume the population is normally distributed. Test the claim at the 5% level of significance. Okay, so my hypotheses, I have my null, u is equal, and I have my alternate, and I've got to look for what the average of the population is. And it says an insurance company claims that the average automobile on the road today is less than 6 years old. So that tells me that this is 6 and that the alternate is less than 6. Now, this tells me left-tailed test, but I've got to decide, do I draw my little curve or do I write one-tail area or two-tail area? And what you're looking for is, since it says that this is a sample standard deviation, then I know less than, I'm looking for one tail area on the student's t-distribution table. So step 2 is your test statistic, and we had a sample of 15 cars, and those 15 cars had an average, or X bar, of 5.4 years, and a sample standard deviation S of 1.1 years. And again, since this is the standard deviation from the sample, then I know I am calculating a t-value, and I'll use the student's t-distribution. So it is 5.4 minus 6 divided by 1.1 divided by the square root of 15. See if I can enter it correctly this time. Fraction 5.4 minus 6, fraction 1.1, the square root of 15, negative 2.11. Okay, so now we're going to take that test statistic and we're going to find the p-value in step 3. Now, since I have the sample standard deviation, I'm going to use the student's t-distribution table. So that tells me I need the DF, which will be 15 minus 1, or 14. And then I need to recognize and remember that the student's t-distribution does not have any negative values on it. So for purposes of the table, then I'm going to be looking for t of positive 2.11. Now again, my actual test statistic is negative 2.11. So if WebAssign asks for the test statistic, you give the negative value. But for purposes of the table, I'm looking for its positive. Okay, so, whoops, let me erase what I'd written on the last example so we don't get that confused. Okay, my DF is 14. And I'm looking for 2.11. So here's 2.14, so it's between these two numbers, and this is a one-tail area. So I come up here to the top, and I'm going to use these two numbers, 0.05 and 0.025. So my p-value is between 0.025 and 0.05. Okay, so in step 4, my decision, I'm going to compare my p-value, which is basically between 2.5% and 5%, and my alpha, which is 5%. Okay, this is one we have to be a little careful on. So I'm going to draw my little number line again. So here's 1%. Here's 5%. Okay, so the p-value is between 2.5 and 5. Now it's between 5. Here's where you need to be careful. So here's my p-value. It's not 2.5 and it's not 5. And why that's important is because your alpha is 5%. Well, we can see the p-value, although very close, is less than alpha. So when it's less than, we reject the null. And when we reject, that means we have sufficient evidence. So there is sufficient evidence to conclude the average automobile on the road is less than 6 years old. So that is 2 examples of all 5 steps. Now, what is different about this is on step 4, no, I take that back. Step 3, when you calculate your p-value, we get that it's between 2 numbers. We don't get the exact value. If you have a TI 83 or an 84, I'm going to show you how you can find the exact p-value. So I'm going to go back to the first example, which was the average cost for a family. So it tells me the p-value is between 0.02 and 0.05. So let me show you how to do this on a calculator if you have one like this. Now the multi-view does not do this, so that's fine. Okay, let me turn it on. So what you're going to do is you're going to push the stat button and you're going to right arrow over to where it says tests. And if you'll see, number 2 says t-test, so I'm going to hit enter. Well, your calculator might be blinking data. Well, we don't have the original data. So what you want to do is right arrow over to stats and hit enter. And then you're going to come down here to where it says mu sub 0. That is the null. And so on this example, our null is 172. And I'm going to down arrow to X bar. We were given that X bar is 189.34. And we were given that the standard deviation is 33.65. And N is 22. And my alternate hypothesis is an is not equal to, and then I'm going to click calculate, and if you'll see right here, there's the t-value, 2.416, which is our 2.42, and then the next one where it says p, it gives us our exact p-value. So on the calculator, the exact p-value, so if you did this on, let's see. If you did this on the calculator, then your p-value equals 0.025. So if you did this on the calculator, and 0.025 is between these 2 numbers. Now it's closer to this one, but it is between it. So let's do the last one too, and I'll show you how to do that on a calculator as well. And again, this only works if you're on the TI 83 or 84. Okay, so I cleared it out. I'm going to go to stat, right arrow over to tests, and then I'm going to go down to 2, which is the t-test. Now if you'll see, it has all of our old information in there. I'm going to leave it on stats. But now for the null, I'm going to delete out 172 and I'm going to put in 6. The X bar, I'm going to delete out what number we had in there, and let me see, X bar is 5.4. S is 1.1. N is 15. And now we have a less than, and I'm going to go to calculate and hit enter. So let's compare. We calculated the t to be negative 2.11, and sure enough, that's what it is. And then for the calculator, it says so on the calculator, it says that the p-value is equal to approximately 0.027. And if you'll look, 0.027 is between these 2 numbers. And again, it's closer to this one, but it is between these 2. So there's how to find the exact p-value if you have the correct calculator.